At this point, we are going to focus on the arithmetic sequence. Let us consider this illustrative example number 1. What is the 10th term of the arithmetic sequence 5, 12, 19, 26, and so forth? So obviously, this is an infinite sequence, particularly an arithmetic sequence. What are the given? The first number that you see here, the 10th term, will automatically be the value of your n as 10. The second one is you will see the first term in the sequence as a sub 1 is equals to 5. Most importantly, you need to determine the common difference. So if you pick 19 or 26 or any number except the first term, you just subtract that number to that. If you pick 12, we need to subtract it to 5. So the common difference of this will be 7. This time, we need to apply the formula or the notation of the arithmetic sequence a sub n is equal to a sub 1 plus common difference multiplied to n minus 1. All you have to do is just substitute the value. Instead of a sub n, you are going to write a sub 10. So n becomes 10 because that's the value of n. The first term will be a sub 1 as 5 plus the common difference is 7. Again, we need to write n as 10 subtracted to 1. All letters becomes numbers. Then, you just simplify it. Do not add 5 plus 7 because according to the rule of PEMDAS, you need to simplify first the parentheses, the exponent, the multiplication, division, addition, and subtraction. In this case, you need to simplify parentheses. You need to rewrite 5 plus 7, 10 minus 1 is 9. Then we got a sub 10. Again, do not add this one. Multiply first. 7 times 9 is 63. And finally, the final answer for that a sub 10 or the 10th term is 68. What if the given sequence is in descending order? Let us consider this example. Illustrative example number 2. What is the 15th term of the arithmetic sequence negative 2, negative 5, negative 8, negative 11, negative 14, and so forth? Remember that it will differ on the arrangement if it is ascending or descending. Of course, we need to give the value of the given. So that the first number that you see, the nth term, will be the value of n as 15. Then we have the first term or a sub 1 is negative 2. And the common difference, we are going to subtract, pick a number here. Let's say we pick negative 5, subtract 2. Before that 5 will be the negative 2. You just subtract, same sign becomes plus 2. And the common difference becomes negative 3. If you remember my explanation about the sequence, about the common difference, if the given sequence is in ascending order, the value of the common difference is positive. But in this case, the given is in descending order. We expect that the value of the common difference is negative. Let us continue using the notation a sub n is equal to a sub 1 plus quantity n minus 1 times d. Okay, in this notation, it doesn't matter if the value of d is here or here. You just multiply that value into the quantity of n minus 1. So it doesn't matter if the d can be found here or. Then we are going to substitute the value of n as 15. A first term is negative 2 plus 15 minus 1 multiplied to the common difference of negative 3. So a sub 15 is equal to negative 2 plus 14 multiplied to negative 3. Then we got a sub 15 is equal to negative 2 plus multiply 14 and 3 is negative 42. Then a sub 15 is equal to negative 2 minus 42. Why it became minus here? Because the rule of addition and subtraction, if the signs are different, therefore you need to use the minus sign. Then finally, we have a sub 15 is equal to negative 44. So this is our final answer. The question is, how sure we are that this answer is legitimate? Let us use manual checking. Let us use the manual checking. We can only apply manual checking if the sequence is to prove that the answer is correct. So let's start with this. Negative 2, negative 5, negative 8, negative 11, negative 14. So if we are going to rank this as the first term, the second term, third term, fourth term, fifth term, meaning we need to supply the 6th, the 7th, the 8th term, the 9th term, 10th term, the 11th, the 12th, the 13th, the 14th, and the 15th term. Since we are going to solve for the 15th term, this value should be equivalent to negative 44. Let us fill out all of these blanks here. So this is the 6th term, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So the common difference is 3. So after 14, we have 17. We have negative 20, negative 23, negative 26, negative 29, negative 32, negative 35, negative 38, negative 41, and we have negative 44. So this answer reflects in applying the notation. Therefore, this solution is correct and valid. Don't forget to follow my Facebook page, Learn Mathematics, and also my Facebook, Trademark Blog, and in my YouTube account, Trademark TV. Thank you, and see you on my next video.